This is what you should see when you load up the computer program. Ensure that you've clicked the Simple Model button within the General Control section. This is because we'll be referring to short loop nephrons rather than long loop nephrons. So the loop is first filled with isotonic fluid from the proximal convoluted tubule, and this has an osmolality of around 290 milliosmoles. It enters the descending limb of the loop of Henle, which is highly permeable to water due to the presence of aquaporin 1 in its tubular walls. So as it moves down, the water moves across the tubular wall into the medullary space, making the filtrate's osmolality increase. It also has a very low salt permeability. So therefore, when you were testing out this computer program, you should have increased the water permeability by a large increment to around, let's say, 100 arbitrary units. And there should have been no salt pumping and a very low salt permeability as well. The filtrate continues to the ascending limb. So as we previously said, there's only a thick ascending limb within the short loop nephrons. Thick ascending limb is impermeable to water as no aquaporin is present. Instead, sodium, chloride and potassium are actively transported into the medullary space, making the filtrate hypotonic, which has a higher water potential. Therefore, you should have increased the salt pumping parameter. We'll increase this to around 100 as well. But the salt and water permeability should have remained low/0. So active transport of these ions from the thick ascending limb makes the interstitium hypertonic, thereby creating an osmotic pressure drawing water from the descending limb into the hyperosmolar medullary space. We also need to change the parameters of the collecting duct. So let's say in a state of antidiuresis, the water permeability in the collecting duct is around 100, and there's like a very small salt pumping. As you can see, by changing all these parameters, you should see an increase in the osmolality of the fluid as you go down the descending limb. Right here, it goes from about 293 to 413. When the fluid moves back up the ascending limb, the concentration of sodium chloride decreases, as does the osmolality because salt is being pumped back into the interstitium. And as you can see in the interstitium, there is an increasing osmolality as you go down slightly. There is also around a 200 millimolar difference at each level between the ascending limb and the interstitium. If you're struggling to see this, you would like to decrease the inflow and see what happens. So in summary, water moves out here, the osmolality increases, and as you move into the ascending limb, the osmolality decreases as salt pumping moves the salt into the surrounding interstitium.